In my last video, I spoke to Alex Grudzinski from Texas Instruments about their 32-bit general-purpose MSPM0 microcontrollers. Not only that, she challenged me to a CodeOff. Well, actually a zero CodeOff. Let's find out how easy it really is to code these things. Welcome back, Alex. Great to see you again. So in our last video, you were slowly convincing me of the benefits of MSP0 Code Studio, a zero-code programming environment for the MSPM0 family of microcontrollers. Now, as a Gen X developer who likes to see all the code in front of me, I'm still feeling a little bit skeptical about it all. You're a Gen Z engineer. Tell me again why my desire to program in C and assembler no longer makes sense in this day and age.
Yeah, I feel like at this time, automation is just everywhere and super important. While it's valuable to get into the weeds, understand truly the knowledge of what's going on behind the scenes in order to keep up with this fast-paced world, it's really important to be able to have all the tools at your fingertips in order to do that. So that's a big reason why we wanted to have MSPM0 to help with that automation factor.
Now, you've kindly sent me a couple of LaunchPad boards to test my code on during our competition. Why don't you just quickly walk us through them?
Yeah, of course. So here today we have two different LaunchPads from two of the different families. Starting off with the tiny one, we have our MSPM0C LaunchPad. Here it has the onboard XDS 110 debugger. And as you can see, this tiny black dot here is the 20-pin package, the superset for this low-cost device family. On this board, there's the reset button as well as a switch you can use in your applications and one LED. Then hopping on over, we do have a board for our low-power MSPM0L device family, the L1306. So same case, it has the onboard debugger, the headers in the common booster pack format. And as you can see, here is that superset 32-pin device for this family. And compared to the smaller size MSPM0C device family and the LaunchPad here, it's a little bit bigger. So you're able to hit and get two different switches, an RGB LED, and also some more features on this front.
Now, in our last chat, you claimed it's possible to build a working application, and that means develop the code and flash it to the microcontroller in under 10 minutes using this zero-code approach. Was that right?
Yes, that's correct.
Okay, so let's see who's fastest at getting a zero-code MSPM0 application up and running. Are you ready?
You're on.
Okay, let's go from zero to hero. Now, before we get started, let's just set the rules. We're both targeting the MSPM0 L1306 LaunchPad development kit with a slightly extended Hello World application. So this is what we need to deliver. When button S1 is pressed, we're going to toggle the red and green LEDs in the RGB LED on the board. After that, you need to output the message, Hello MSPM0 World on the UART. And the entire code needs to be in an infinite loop so that the LED toggling and message output can be repeated indefinitely. Are you ready?
Yes, let's do it.
Okay, I've got my stopwatch ready. And let's go. While Alex and myself get into the competition mode and try and beat each other to create that little application I defined, I just wanted to show you how to use MSP0 Code Studio in your web browser. Now, the advantage of it is that you don't need to install a big development environment on your PC, but you do need two little bits of software to make it work. The first is a plugin for your web browser, and the second is a little bit of code called TI Code Agent. And those bits of code make sure that the web browser can actually talk to your board over USB when you're trying to flash the board and get your code running on it. So with that behind us, the next thing to do is to take a look at those LaunchPad boards. I'm going to start with the L1306 board. Now the L1306 board, this is it set up here, as you can see, and I think as Alex described to us previously, it's split into two pieces. On the right hand side here we have the debugger part of the board, and on the other side which you have the microcontroller part of the board, and there's the microcontroller in the middle there. Now the board and the debugger communicate over these set of jumpers here. This is important because if you look down here, that's where the receive and the transmit pins connect through to the debugger interface, and that's going to allow you to communicate with your computer via the USB connector there. Now there's also the two switches here on either side. This is switch 1 on my left and switch 2 on my right, and all the pins of the board brought out to these headers here as well, so you can actually connect them to other things. Along the bottom here there's also some other bits of features that you can use. We've got a red LED with an RGB LED. We have an optical sensor here, and right in the middle there's also a little thermistor which can also be used, and it's also part of the demo code which runs on the board when you get it. Now the other nice thing that comes with the LaunchPad boards are these little printouts, so you can actually see what is connected in terms of the microcontroller pins to which of the headers on the board. And on the back here we also have a little header as well, so that you can connect to other plug-in boards on there as we discussed before. Now of course the other board looks very similar. That's for the C1104. Here the debugger actually takes up most of the space, as you can see. It's an enormous amount of debugger here. Here's the connection to the microcontroller part of the board, and there's the microcontroller there. Some of the header pins are brought out here too. There's that handy guide again, as I mentioned before. There's the USB connector, and there's that input switch, but there's only one LED on this particular board, and that's the difference really as we port the code later from the L1306 to the C1104. So now you've got a great overview of what the boards do. It's time to figure out how we're going to make this code created in MSP0 Code Studio and understand which pins are connected to which features. So now we've seen the boards, we need to take a little bit of a look into the documentation so that we can figure out which pins of the microcontroller are connected to which features on the board. I'm going to take a look at the documentation now. So this is the schematic that comes with the L1306 LaunchPad board, and I've highlighted 3 areas for us here. Now there's the general purpose switches. We're going to be using those, and the important thing to note here is which pin is doing which task. So the PA18 pin, that's connected to switch 1. We've also got the red, green, blue LED. That's down here at the bottom of the board. Now we've just got to take a careful look to see what's there, and as we can see there, that's PA13 is for the green LED, and PA25, or is that PA26? I need to do glasses. That's for the red LED there. So now we've got those 2 pins sorted out. The next part of this is to then look at the UART, because obviously we want to output that UART data. The UART information goes out via the transmit pin to the debugger, and that's via pin PA8. So now we've got a list of pins that we want to target for each of these different features of the application we're building, and that's all described there on the LaunchPad documentation. Now the other interesting part of the documentation, this is from page 6. There's a nice table here which actually reflects the whole thing again. So for the button, for example, that's listed here. We've got the RGB LED on the green channel, that's listed here. We've also got the RGB LED red channel. We want to turn those on together. That's part of the task. Makes it a little bit more complicated for Alex. I hope she's read the documentation so that she makes sure she handles that correctly. And the last thing, of course, is the pin for the transmit side of the UART. Now, there's one more thing we need to do before we get started. I thought it'd be good to have a little block diagram of how everything's connected and set up, so that you can visualize which blocks you need and why, and which pins are connected where. So let's take a quick look at that. So the first thing I'm going to do is draw my MSPM0 here in the middle. So that's MSPM0. And obviously, key thing here is the power supply. So we've got our VCC and we've got our ground pin. Pop those in there. And just let those connect up and down for a second. So we've got something to connect to. Now on the input side, we've got, as I said before, we've got the PA16 pin that's connected to our switch. Now if we look at the circuit diagram, what you'll notice here as well is that the switch is connected to VCC, that's 3.3 volts, and there's a pull down resistor on the other side. So that's what we're going to replicate here, just as we know exactly what we're dealing with. Nice simplified version of what's going on. Put the switch in there and our 3.3 volt supply that goes across the top there. Now the other thing of course is the UART output, so let's put our transmit pin on there and make a note that that is for the output. And that was pin PA8. And then we've got those red and green LED pins. Now, whoops, there we go. Now they actually go through a current limiting resistor in both cases before they actually get to the to the diode, to the LED. So let's pop that in there. There we have it, two of those. And the two pins there were PA13, that was for the green, and PA26 for the red. So with that we have a nice overview, a simplified overview of what's going on and what we're trying to do. And we also have that nice list of pins. Now with the pins, what's important is that later I asked Alex to port the code to the C1104 board to show you how simple it is to switch from one microcontroller family to another. So what I'm going to do is I'm going to create a small table here, so as we've got a list of capabilities on the board and the pins on the L1306. We're also going to find out how that works then on the C1104 to help us with that switching process. So let's make a quick list here. We've got S1, and on the L1306, that was pin PA16. We've got the transmit pin of the UART, that's on PA8. We've got LED green, that's PA13. And we've got LED red, that's on PA26. Now if we take a look at the C1104 circuit diagram, what we're going to see here is that it's a little bit simplified. As I said before, there's only one LED and there's only one switch available. Obviously that makes it easier to find the right things to connect to, and there's also the same transmit pin across to the debugger, and I've highlighted them here on the schematic from the LaunchPad documentation. This was page 8 for the LaunchPad documentation of the C1104. And I've made a quick note here just so that we can check as we do that switching process, that migration process from the L1306 across to the 1104, the C1104, that we've actually got the right pins as we're doing that. Now the user button, that is on PA16. So that actually stays the same. The transmit pin is on PA27, so that's going to change. The LED green, that doesn't exist on the other board, so we'll cross that one off. And the red LED is connected to PA22. Okay, so there we have it, Morris, but I think actually I've just seen a mistake. Yeah, here on the schematics for the L1306, that input is on pin PA18, and I've incorrectly marked it as PA16. So let's just change that there. And of course over here as well. So that was, oh dear, a little mistake there. So there's PA18, and PA18. Of course, then when that gets ported across to the C1104 board, that's going to be on pin PA16. Super. So now we've got a nice table there, and that will help us as we do that migration process and just check that the software environment has selected the right pins for us. So now it's time to get MSP0 Code Studio up and running. Now we can create an empty project. That's obviously our starting point for the competition, and we need to then drag and drop those blocks in. So we've got the button toggle, we've got the button capture, we've got the LED toggle for the 2 LEDs on the 1306 board, and we've got the UART output. So we put all of those blocks in. We can go in and check that the pin configurations are correct. The important thing here is for the LEDs is that we need to have a different configuration code for each new LED we add. So that's an important step. If you don't do that, each block will try to reconfigure and control the same LED. Once you've got that up and running, you can check to make sure the pin configuration is okay. Take a look at that window, make sure everything is in order there before you get going. And as soon as you've got there, it's a case of building and loading the application. Get it down onto the board, and hopefully as you press the button, you'll see the output on the terminal. And you can also take a look at the LED toggling. Now I'm just going to connect my boards here to show you how that works. So I've got the L1306 board here. I'm just connecting it to the PC. We can see that the debug LEDs come to light. Code's downloaded on the board. And now all I need to do is press the button on the side there. We can see that the 2 LEDs, the green and the red one, toggle on and toggle off as we press the button there. We'll just go over to the C1104 board as well. We've flashed that also with the same code, but obviously migrated for the pins that are on this board. And again, as we press the assigned button, the LED toggles on and off. I think you'll agree it's dead easy to get your code up and running, and of course you can add anything you want like serial interfaces and PWMs from that list of capabilities on the left hand side of Zero Code Studio. Now if you're thinking, so what happens next once I've got that prototype code up and running, how can I progress? Well, if you want to move further and get more into a C programming style environment, there's Code Composer Studio that supports MSPM0, and on top of that there's also the MSPM0 SDK which you can download. There's all the APIs there and loads of examples showing you how to get your code up and running. Okay, let's get back and see how Alex has been doing with the competition.
Hey, Stuart, I'm done. Stop the clock.
Okay, Alex, hang on a second. I'm almost there. Oh, I think I'm done as well. Yep, I think it's working now. Oh, that was difficult. Right. Okay. So, your board's working as expected. My board's working as expected as well. Let's compare the times and see who won. Right, Alex, you're up first. Now, you came in at a time of, let me look here, 7 minutes and 4 seconds. And let me just check my time. Hang on a second. Just have a look here. Now, I completed the task in 7 minutes and 56 seconds. So congratulations, Alex. A well-deserved victory for the MSPM0 hero. And I have to admit, I'm really impressed how quickly we got this code up and running. We've checked the details in the LaunchPad datasheet. We've put the code together and waited for it to compile. I think compiling took longer than actually writing the code.
Exactly.
I mean, I know that if I'd taken a more classic approach, I would have been been busy for half a day installing the tools and reading compiler documentation and data sheets. So yeah, well done, and thanks for setting me up with that competition. I've learned a lot from that. I guess one of the last things I'm curious about, and we did talk about this in the last video as well, but how will we move this application from the device that we've got it on now to another one like that C1104 board? You said there's a lot of compatibility between the MSPM0 families. Could you show us how that would be done?
Yes. So it's relatively straightforward. So similarly to what we showed last video, you would go over into the device view. So here you can see in the bottom right corner all of the different options here. It's as simple as hitting switch. One caveat on the M0L1306 LaunchPad, there's one more LED than there is on the M0C LaunchPad. So that's just something you'll run into while moving over. If you want all of the pins to be the exact same, you would select lock resource allocation. But if you're just looking for the same functionality, this allows some more fluidity between. So then you can just hit confirm. It'll migrate stuff over. Get a little mad at me because there's two LEDs.
Yeah, of course, yeah.
So it's as simple as changing that, moving this over, and then picking the pin for the LED for the smaller LaunchPad.
Yeah, super. That is so clever. Alex, I think that what I've learned is not to be so skeptical about new tools for developing applications for microcontrollers. Thanks so much for taking the time to guide me through the zero code approach to software development. I'm really grateful. Thanks.
Of course. Thank you for having me, and thank you for giving me a run for my money.
You're welcome. We're definitely, next time you're over in Munich or over in Germany, we're going to do another CodeOff live maybe.
Ooh, that could be fun. I'll hold you to it.
Well, I'm pretty impressed with the zero-code approach to application development on the MSPM0. Firstly, the development environment is accessible through my browser, so I don't even need to install any software. And thanks to the graphical programming approach, it's really easy to configure the peripherals you want to use and make the microcontroller do what you want. On top of all that, the capabilities of the LaunchPad boards are recognized straight away, ensuring the chance that you make a mistake is pretty slim. It's a far cry from the bare metal programming approach I and many others grew up with, where you needed to understand the function of 30 or more registers just to output a byte of data or toggle a GPIO pin. Now, admittedly, there are limits, but if your goal is to rapidly test an application idea with the MSPM0, Zero Code Studio plus a LaunchPad board can really deliver first results in less than 10 minutes. Some of the things I'd definitely be considering for this setup are things like sending sensor data to a PC, logging data to an E2 PROM, or even controlling a motor or fan, because all the serial interfaces, button presses, PWMs and flashing LEDs are so simple to implement. Now, if you're interested in giving the MSPM0 family a try, you can start with MSP Zero Code Studio in your browser right now. Just visit ti.com/MSPM0, scroll down and click on Software. Then order yourself a LaunchPad board, which you'll find on the same page under Hardware. And if you want to go even further, there's also a range of educational resources there too. My thanks, of course, go to Alex for patiently guiding me through the zero-code programming approach for MSPM0, and I hope you've learned as much as I have about this fascinating family of 32-bit general-purpose microcontrollers.